per your, you know, uh, uh, as per the SOPs needed to understand. This is a very documentation thing, not a technical thing. So we will take this into as a separate session or last session, because it's not very important to discuss as of now as in the very beginning, because you must know the uh, uh, very specification about the device, how to identify the device in what state, in which state. Then you come to know about what to put into acquisition forms. Okay, so now acquisition acquisition part. Okay, so acquisition, that is means data collection from any accident, from any accident. Okay, and what we have discussed, we create how many copies of acquired data? Does anyone remember? हम
So
कितनी
two
copies acquire करते हैं? Two copies. Okay, two copies. One is master copy, okay, or original copy, and working copy. So master copy, original copy is the same thing. It varies from industry to industry. People in government used to comfortable with the master copy word, and people in private sector, they are more convenient with original copy word. Okay, so we always have to work with working copy. Okay, and okay, let's talk about a storage device. It could be a hard drive, it could be a pen drive. Okay, irrespective to the interface, because there are different interface available in the market. And okay, so can you name any five interfaces? Name any five interfaces or interfaces, and don't use your Google or Chat GPT, because you are learning here. You cannot use Chat GPT and Google when you face to an interviewer. Okay, so the
graphical
more
interface,
uh, so for storage
command
device.
lines. Okay.
Okay, tell me one by one. Let me help you with first. Uh, SATA.
That's,
Has anybody never heard of the word SATA?
no, sir.
Okay, so let me show you.
A Kali Linux runs on SATA.
Sorry, can you please speak loudly?
Kali Linux, Kali
Sir,
Linux runs on
SATA,
SATA.
sir, SATA is a hardware, sir. This is
Yes, yes. So I'm asking
hardware.
about the interfaces of a storage device. Means
Sorry, USB.
what
Hardware,
means
HDD, sir. SATA is
you
HDD.
connect
NVMe,
your
sir.
HDD, hard disk drive.
so SATA. Kali Linux, so you told Kali Linux is an operating system. It's not an interface. Okay. So SATA, and one of the guys said NVMe. Okay. Third one, try to
Pen drive.
remember something. Come again.
USB, sir.
Yes,
USB.
USB.
Then we have
So hard disk and pen drives will be counted in interface.
Yeah. Hard disk, pen drive, mobile phone.
Memory card.
Okay, memory card, everything comes in parallel in communication. So it uses either USB or
So
NVMe.
cloud-based data, sir.
No. Storage device. A storage device
Storage.
interface. Okay, so if you talk about cloud, let me explain you. Cloud works remote in a remote manner. but at some point it is a physical storage device. At some point, okay, in any point of the world, storage device, and it runs some storage hardwares inside it, and those hardwares have some interfaces. Okay, so SATA, NVMe, USB, there is called PATA or IDE. There is an interface called SAS. There is an interface called SKZ. Okay, so there are major interfaces, but nowadays people have C-type also, but C-type again goes in USB. It's a family of interface, okay, or micro, which is the earlier version of मोबाइल फोन्स. आपने देखा होगा पुराने मोबाइल फोन में सी टाइप नहीं होता था, एक कनेक्टर होता था, राइट? ओके, सो SATA is the very common storage so interface, and its full form is serial ATA. ATA means advanced technology attachment. Okay. Now this is serial, right? This is serial. Serial means one by one. So the opposite of this is PATA. So this is parallel ATA. These are obsolete in the industry now. Okay, these are obsolete. Why? Because their bandwidth, their data transfer speed is very less. Okay, and that's why industry introduced SATA. That's why. So these are obsolete ones. So we have SATA. Now SATA also reached to its peak capacity. Therefore, now we have NVMEs. These are parallel flash storages. Okay, flash storages. These are again two different protocols or interfaces. This is a small computer system interface, SKZ. So this is a parallel one, and there is a serial, a serial attached SKZ, SCSI. Okay, so this is the advanced one, but they are used where? They are not used in by end user market. Students, professional, they don't use it. It is used in enterprise. Enterprises means data centers, servers. Okay, these are again obsolete, and it has again a limitation that it is lesser as compared to SAS, lesser in terms of bandwidth, data transfer speeds. That's why industry introduced SAS, but they goes in enterprises. They are very costly hard drives. Okay, and nowadays we have in our computers is SATA hard drives and NVMEs. Okay, USB device is plug and play. You can carry your hard drive in your bag and you can use it on your laptop wherever, whenever. Okay, this is again obsolete one, and these are again obsolete one. Okay, so SAS, USB, NVMe, SATA, they are nowadays used in day-to-day life. Okay, so let me again show you. So depending on the type of interfaces, there is a device called digital duplicator. Okay, digital duplicator. So there are different kind of duplicators available in the entire world in forensic industry, and each duplicator works in similar way as compared to its rival duplicator, but there are differences in functioning, some down features, and all duplicators support all the ongoing storage interfaces in the market, whether it is SATA, it is USB, it is NVMe, and each and every duplicator supports this kind of provision to connect your your data, your storage device. Okay, so here you can see in this photo. So this black device is a duplicator. On left portion, I will show you in more detailed manner about it, but it's on hand side, okay, and your destination will contain the empty hard disk. This is the general rule of forensic. And you should listen it very carefully. It's very important. It's a basic of this forensics. Okay, so we are in discussion of this forensics, and I will share you the material also, and including some software also at the end of this session. I'm going to show you some software how to do forensic imaging, and all it's at your laptop, this forensics. So this is the topic of this forensics. In this forensics, we are discussing acquisition, which is the third step of SOP in DFIR. Okay. So in this forensics, there is a device called disk duplicator. And it's a hardware. It's a hardware. Okay. There are this duplicator hardware, and there are disk duplication software. Okay. So it's a software. As the name suggests, it's a software. So when you come to our own, you want to go for hands-on training in our office, you will experience this thing. I will show you in video also for remote training, and in both manner, offline and online, you are going to experience this in your own machine. I will share you the software and with material how to perform it. Okay. So what does it do? So hardware. If I talk about hardware, so hardware has two sides. One is source side, and other is destination side. Okay, destination side. Source side is write block. Okay. So listen this very carefully. We want data integrity to be maintained in DFIR. Okay. So if any of the bits got altered, so hash value got altered. So that's why we need to ensure that no data will get altered. It means whatever data is inside the storage device, it should come out as it is. So it's a one-way communication. It should be one-way communication. Okay. So write blocking device, what it do? Write blocker. It's a one-way communication. Okay. Means you can read only, but not write. In this way, if any duplicator, if you have a different hardware or a different write blocker, so we will take a separate session of write blocker. So write blocker is also a device, a hardware device of different interfaces. SATA write blocker is different. PATA write blocker is different. Okay. USB write blocker is different. So it's like a small kind of hardware device as similarly as the size of hard disk. Okay. So when you connect your evidence, your exhibit to a write blocker, and then you connect your write blocker to your laptop or your computer, then you can explore the data, whatever is in the hard disk. Okay, you can view it, you can open the file, but you cannot alter any name, you cannot change the metadata, you cannot write anything on it. Okay, even you cannot create a folder on it. In this manner, the whole integrity is managed, is intact, and your data is safe. Okay, so this is one of the feature of Write Blocker. Write Blocker is also used in such a way that, let's say, if your laptop has some malware going on, okay, some infected files is there. As soon as you connect any storage device to your laptop or to your computer, the malicious files got transferred by itself without the intervention of user. Okay. So, but in the presence of Write Blocker, if you mute कर लीजिए, please mute yourself. Whoever is speaking. Akash Srivastava wants a presentation in the group. Okay, I will share the presentation, and I will share a lot more literature to you. And Akash will share. I will tell Akash to share it with you. Okay. So let's say somebody mic is open. Rajiv Kumar. Rajiv, can you mute yourself? Okay. So let's say your laptop has some malware, malicious files going on, or it is infected. Okay. And you connect, you want to explore the data of your, you have an exhibit in the form of USB hard disk, and you want to hard disk to your analysis computer, whatever is in there, it got transferred into your exhibit, and exhibit hash value will get changed because the file entries got changed. The timestamps will get altered. So that's why in the presence of Write Blocker, you cannot do anything. Whether you have a infected machine or not, and your exhibit, when you connect to Write Blocker and then Write Blocker to your forensic laptop, okay, then you are not able to do anything on your exhibit. It is completely safe, completely intact. So in this way, you can maintain the integrity, and maintaining the integrity is the fundamental thing in forensics, digital forensics. Okay. So these duplicators, they have integrated Write Blockers. Okay. These duplicators, they have integrated Write Blocker. Okay. But in this duplication in terms of software, we have to have the extra or add-on Write Blocker. Okay. So I'm going to show you when you are in the office the Write Blocker, how does it look like, and Write Blocker and this duplicator also. In remote manner also, I will show you through some video and how does it look like. So stop presenting first. Here is a video. Okay. So insurance. Okay. This is the Write Blocker from Tableau company. And okay, so this gray device, gray and orange device, this is a write blocker, and it has the ports in their own body. It is housed in a single body. On right hand side, as you can see over here, there are ports which will let you connect your destination drive, and destination drive in which you want to make a forensic image. Okay, so your destination drive should be empty. It must have a free space. Okay, this is the front of the padlock disk duplicator, and this screen is a touch screen. Okay, here you can select and make the options. When I show you the FTK measure thing, when you create a forensic image, what options you need to take care of. Okay, so this is the options. It will guide you about target device and source device which you want to take, and this is the on the left hand portion, you can see the screen. Here you control your hardware, and on the right hand, it's a added module which will connect on the beneath surface of this screen. Okay, so it mainly lets you connect the SATA hard drives so that you can insert your drive into it. It just mainly used to increase the storage capacity of your forensic duplicator so that you can create one or more copies. These are USB ports in which you can connect your pen drives to collect logs, how many forensic images you have done, what are their timestamps. Okay, these are mainly can be used as a destination ports. On left hand, there is a source port in which you have to connect your exhibits, whether it could be a hard drive, it could be a pen drive. Okay, but not mobile phone. Mobile phone acquisition is completely different. Forensic duplicator allow mobile phone. So you can see over here, this is a power port, this is a SATA port, this is a SATA port, this is a power port, and this is a USB port. So you can connect your SATA hard drive over here, you can connect your SATA hard drive as a destination over here, and you can connect a USB drive as a destination over here, and simultaneously, all at once. So behind, there is a power button and there is a Ethernet port. Here you can connect your duplicator and then your computer so that you can use that duplicator interface on your browser also. Okay, instead of using on the screen, you can use and control this duplicator on your browser also. So these are the source ports. Okay, so FireWire ports. Ever heard of FireWire? People we have. Okay. So FireWire ports, it is mainly used to connect Apple devices like Apple Time Machine, Apple hard drive, external drives, and Apple computers. Okay. These are USB. If you have a pen drive as an exhibit, you can connect it over here. If you have an external drive as exhibit, you can connect over here. These are again SATA ports, power port and data port, power port and data port, and this is PCIe. Okay, PCIe means all the parallel flash storage device, just like NVMe. Okay, so it's basically external module. Here you can connect an adapter, and on that adapter you can connect your flash storages like NVMe's and other stuff. So this is okay. So this is the second thing. So on these two slots, it goes here your SATA hard drives. It goes inside these boxes. Okay, so and this complete gray box can attach on the below surface of this forensic duplicator. So it's mainly to increase to populate the hard drives so that you can one source drive and you can have a multiple forensic images at the same time. Let's say one here, and other are on a destination ends. So 4 to 5 images you can create at a single time of single forensic exhibit. And this is the latest one in the industry, TX1. So whenever you have been asked upon in an interview that what forensic duplicators you know, so if you say about TX1, so let me show you about this one, why it is important. So this is the first hardware device. This Tableau company. Tableau is the company name, and TX1 is the model series of this duplicator. Okay, so this is, and it doesn't require any separate write locker. It has an integrated write locker. Okay, these are the further attachments, adapters, and for PCI attachments, if you have a NVMe, you can connect to your adapter and then to a PCI. So this is about TX1. Now let me show you the software imaging so that you can do at your own computer in your free time. So there is a software, a universal software called FTK Imager. Okay, so it's again a very reputed software in forensics industry. So it's a hardware. Second is software, and its name is Xtero is a company name, and FTK is a product series, and Imager is the software name. Xtero FTK Imager. So this is the forensic imager I have opened. Okay, now go to file. Okay, it says add evidence item. I have connected a pen drive to it.
स्टेगनोग्राफी के लिए कौन सा सॉफ्टवेयर यूज करते हैं
Sorry, come again.
सर स्टेगनोग्राफी के लिए कौन सा सॉफ्टवेयर यूज करते हैं
Steganography is an analysis thing in which you use magnet, and you use FTK suite, you use NCase, okay, Stego Hunt.
ओके
So for corporate, for enterprises, the softwares are different. For low range working, low cost working, the softwares are different. Okay, so you create here, create disk image, the first step. What you want, a physical drive, a logical drive, an image file. So one by one, let me have this one. I want to create a physical drive image. What happened here is that, let me show you in my PC. Okay, so let's say I have a computer in which there is a single hard disk, and you have to create two partitions into it. Okay, this is how it goes normally. Okay, so if I want to create a forensic image of your computer, then I must need both of the partitions. So I want to have a physical hard drive. Okay, I want to have a physical hard drive image. How? Let me guide you. So this is disk management. When you explore disk management on a computer, if you have a MacBook, Apple computer, then you can go to disk utilities. Okay, so there are three disks are connected to my PC. Okay, disk 0, disk 1, and disk 2. Okay, so disk 0 is one separate disk. Disk 1 is another separate disk. Disk 2 is another separate disk. But what people usually do in our regular practice, they create multiple partitions into single drive. So C drive here come here, D drive come here, and then E, then F, and so on. Okay, I'm not talking about another hard drive partitions. So single hard drive may have different partitions. Okay, but if you want to create a physical image, you don't have to select each and every partitions in a single drive. Instead, you have to select the complete hard drive itself to create a physical image, because physical image will carries each and everything. How? Let me show you. This is a single hard drive. It has a single partition called C partition. Okay, it is 475.96 GB. Okay, so but it's actually a 500 GB drive, and this one it's a 1 terabyte, and this is a pen drive connected of 16 GB, I think. So disk 0 is a C drive. It has boot partition. When you switch on your computer, the bootloader will get activated. It will help operating system to get boot up. Okay, it has page file. Page file is basically what? Have you ever experienced to transfer a file bigger than your RAM? Or have you ever experienced that your RAM is already in use and still you are doing multiple process in your computer? So page file works in that way, because let's say you have a laptop of 16 gigs of RAM. Okay, 16 GB, you have a RAM which is a sufficient primary storage. Okay, you want to run a program which is only possible on 16 GB. Okay, so try to listen it very carefully, because this is very tricky thing, and once it is skipped, you are very disoriented or zone out from here. Let's say you have a laptop of 16 GB RAM. Okay, and you want to run a program that needs 16 GB. Okay, are you able to do it? Say yes or no.
Yes.
Okay, now if you have a 16 GB RAM, you must have an operating system running in your PC. You
Yes.
must have a
Yes, sir.
you must have a background apps running in your PC continuously. Okay, and let's say you do browsing, which consumes a heavy storage on your PC. So it eats a lot of RAM. But on a separate, you want to run a software which needs pure 16 GB RAM, nothing else, not lesser than 16 GB. But can you run a 16 GB program if you have this much of running in your PC? Is it possible?
No, sir.
No,
No,
sir.
sir.
No, sir.
Okay. Okay. So the answer is yes, it is possible. How? Through paging system. Okay. Paging system, your HDD, your hard drive in the computer can work as a RAM. Okay. It is recommended by manufacturers of computer, or you can see in when you purchase a new laptop or a new Windows or new licenses of Windows, it is recommended that you purchase a new external hard drive. It is recommended or written over there that you have to use up to 80% of your storage capacity. Means if you have a 1 terabyte of hard drive, then it is recommended not to use the storage above 800 GB, because around 10 to 20% of storage volume is by default goes into RAM, and that storage part can work as a paging, okay, page by pages for, and it delivers or directly maps to RAM. So you have a dedicated RAM of 16 GB. And after 16 GB, if computer wants more amount of memory, then it will take out from your hard drive. That's why it is said that if you are using hard disk drive at 100% capacity, sometimes you see in your my computer your these partitions, this partition goes red instead of blue, okay, and your computer goes slow. So this is when this is happen, because all the storage recommended storage you have used, and the leftover portion which is usable by RAM, you are also consuming it for your own purpose. So at the end, what will you experience? The whole computer goes slow down. Okay. So let us back to the topic. So it has a page file. Okay. And this page file is the log file of how much RAM data is collected on the hard drive, and by which manner, and by what programs is used. So if you skipped RAM in your acquisition, I'm going to discuss RAM acquisition also in your later session. Okay, so you skip RAM and you have a page file. There is still a chance that you may have a data. Okay, and what ongoing programs are there in your PCs. And crash drums. Crash drums means by any means your computer goes blue screen, or it suddenly got freeze, or suddenly got switch off, or some hard drive suddenly shut down itself, or showing clicking sound, or slow responding, then you always this experience some lag, and subsequently what will happen, it will shut down. So all these crash activities are logged into crash dump file. And then comes your basic data partition. Whatever data you stored in your C drive, E drive, okay, C volume, E volume, it goes here. Okay, so this is a healthy. Healthy means it's a file system is working very properly. All the entries are mapped into each other. There is no file corruption. Okay, now let's say my laptop, which you can see on the screen, goes into bad state, goes into unhealthy state. Now what will happen? OS will try to reboot itself and try to find out what actually happened and how to recover the data, how to restore the state on which the computer is working. So whatever logs OS will take, it takes from here. That's why it is called as recovery partition. Okay. Now there is a separate partition called system partition. It is reserved for file system, for operating system to save their jump codes or boot codes, or you can say some basic files which are required to operating system to boot up. Okay, so EFI system partition. So these are three main partitions you can see over here. But let me show you one more thing. Let's say you delete some data from here. Let's say this is a C drive, and you delete, let's say, this data. This folder is 0 bytes. Okay, not this one. Let's say program data. Okay. Okay. So this program data is 12.9 GB, and it contains 6,903 files. Okay. You delete from here. So there are two types of deletion. One is just simply use delete button, or this one delete. But where will it go? It will go to recycle bin. Recycle bin is a part of active healthy partition. Okay, it's a reserved space in the file system, through which you can recover your data very easily, restore data easily. But there is another method of deletion of data which people do intentionally or just to increase the space in your machine, which is shift plus delete. So shift plus delete will completely delete the data from your existing state to another location, which are not the part of file system. Okay. So whatever data you have it will goes beyond this thing from C drive. Okay. So if you have a hard drive, let's say it is 512 GB, how to identify the sizes? There is another way. Go to system and go to device manager and go to disk drives and okay. So I have three different storage devices over here. The generic flash drive, it's a USB device. It's a pen drive, disk number 2, 16 GB. This is NVMe from SK Hynix company, 512 GB. So this is my disk 0. Okay. Now another XPG Gamix. This is 1 terabyte. Okay. So here you can find the ID of a storage device, but these are sufficient numbers which tells you about the storage number. Okay, so let's say you shift delete a data and it goes out from this region and it goes to some unallocated region. So when you delete your data, when you shift plus delete your data, it will go to unallocated region. Unallocated region, which is not a part of active healthy partition. Okay, but it is there in HDD. It means HDD has some spatial area where all unallocated entries it carries. Okay. So when you do physical image, you are telling the computer that I don't want this, I don't want this, I don't want this. I want everything, whatever there is in the hard disk, whatever they are present in the hard disk for user, whatever deleted in the hard disk and is not accessible by the user. Okay. So physical image is that thing. So let's come back to FTK Imager. Second option is a logical drive. Logical drive, as the name suggests, logical. It means logical volume. If I want to create an image of C volume only, if I want to create an image of D volume only. Okay, so volumes. So physical drive is the primary and the sole objective of any forensic examiner to extract out the data. Physical device. Next thing. Now it is asking me what you want. What is your source drive? So this is very a careful step. You need to be considered. You want 012. Here the name convention 012, as you can see in your disk management also. So my source is let's say my evidence is 16 GB pen drive. Okay, now finish it. So here are the options for destination. In image destination, you have to create an add button. Now what you want? You want a raw DD. Raw DD is a clone. It's a clone. Okay. We have discussed two things in acquisition: forensic imaging and forensic cloning. Forensic imaging and forensic cloning both are two different things, but they give the same data. Okay. So raw is clone, but we don't want raw. We want E01. So it's a standard extension for forensic image. There are another extensions also, standards also like SMART. SMART is another forensic clone, and AFF is another advanced format for forensic image. But we don't use all these. We use E01. Raw cloning we use in some special cases, which we'll discuss in later sessions. Why raw is required. So E01 is saying that what is your case number? Let's say my case number is 001. This is the part of documentation. What you are documenting in a physical paper. Here you have to put like what is your evidence number, like you name convented A01. Is there a unique description? Let's say yes. It has some scratches on body. Okay. Your examiner name, let's say examiner name is Jacob. Any special notes? Let's say special notes is not, but uh, uh, single pen drive only. Okay. Image destination folder means where you have to put your destination folder. Browse. Let's say I have a space in my PC. Here you can use, and you have to use, an external storage device to connect your PC. But here I'm just demonstrating you how the things needed to be done, but it requires a write locker. My pen drive cannot connect to my laptop without write locker if it is exhibit. Okay. So destination, here I have to put in D drive. Let's say make a new folder and give it a name test image. Okay. Now image file name आपको क्या रखना है? Let's say pen drive. Okay. Now here important thing. Let's say your forensic image or source drive is 16 GB. Now you want to create a single image file, or you want to make a chunks of it. Let me show you here. Chunks or single image file. Chunks means what? Chunks means whatever chunk size you carry, or whatever fragment size you set. Okay, let's say you set a 500 MB, or it is equivalent to 1.5 GB. Okay, and your source is 16 GB. Okay, so your 16 GB is divided into equal chunks, of 1.5 GB each. Okay, but your primary file is E. Let's say you named it pen drive. You named your image. So primary file is E01, and then later it goes pen drive E02, and then E03, and so on. Okay. After 9, it goes 10, 11, 10, till 20, 30, till it constitutes and takes all the 16 GB. Okay, but single file, if you selected for single file, just this image file is formed. So here is the option. You want to create a fragments or not. Most of the cases, people want fragments, but I will explain you when we do analysis why the fragments are important and why single file is not preferable. Okay, so let's start with do not do any fragment. It says if you do not want any fragment, you have to put 0. Okay, so forensic image file is encoded file and compressed also. You want to create high compression and low compression. Let's say I want a medium compression. So 9 is the smallest, 0 is the very weak compression. You have to put here. There is a encryption provision available here also. You can encrypt your file so that no unauthorized person can access this file. So it's an add-on feature of the of software, but it is not a general rule to put encryption on forensic image. Okay, this is just a advanced provision. Let's say pen drive. Next. Okay, so you have set the destination path in D drive, test image folder, and then pen drive, the file name, and then this. So once image is started, it will ask you whether you want to verify the image. Whatever image you created, it must verify with the source that the hash value of the destination file must match with the hash value of source file. So this is the option. You have to put check on it, that verify images after the creation is done. Now, if you want to calculate the statistics that how much time is left to complete the operation, you can use this machine. This thing is not discussed at this stage because it's an advanced thing. But let me give you a preview of it. Let's say your source. Okay. So there are some golden rules in acquisition. Your source size is must be less than your destination drive. Okay. Means your source, let's say it's 500 GB and it should be lesser than, and the destination is 750 GB or 1 TB hard drive. Okay. This is the golden rule. But let's say you don't have, at that point, you don't have a available 750 GB. You have up to 500 GB destination drive. So what you can do, you can use add overflow location. It means once you create a path where your image goes to in that destination path. Okay, once you selected it, then using this option overflow, you can create a second path. Once first path is completed, the whole capacity is consumed, and then it switch back to the later path, later volume. So this is overflow location. We generally don't prefer this kind of thing in doing acquisition. We only prefer that it's a one-go operation and it should be verified. That's it. Now let's hit the start button and your image is started. This is the data transfer speed. How much time will it take? Approx 14 minutes. And how much data has been done? Around 268 MB, 290 MB. So this is the physical image is going on. In later session, I will explain you how to view the forensic image and how to view the data. Okay. And other stuff also there. So have you got the broader idea of it? I will share you the URL of software. You can download it. You can create a forensic image using a pen drive in your laptop. You can have a destination in your own laptop volume. But make sure to have as a sample, you must have a smaller source size like 8 GB pen drive or 16 GB pen drive. And you must have some data. So it's a good practice if you have some data in your pen drive, present data, and you should delete some data in your pen drive and then do forensic image. Okay. Then do forensic image. So that after forensic image, when you parse out your file in your software, you do analysis, you have a good idea of how deleted data is present, what is the state of it, and how to recover it. Okay. So after this session, I'm going to share some literature also with you for background study and for the notes which we have discussed today. So it will take around 10 minutes. Okay. Now during that thing, let me discuss one important thing, which is let's say you have a 500 GB hard drive. So how much space you have to work in PC? If you have a 500 GB HDD, brand new, you have purchased from market, you connect it to your computer, then how much space does your 500 GB shows? Any idea?
490, 492.
490, 95 around.
Okay, one person said 492. One person said 495. Any other guesses?
Sir, is it an external device, no? From the external device, HDD?
No. It's the internal hard drive of your computer. Okay, let's take 1 terabyte also. Do you know how much 1 terabyte shows in your PC?
Yes, sir. Sir, 1 TB तो सर लैपटॉप में है मेरे, तो मतलब वो भी ऐसे वन।
Okay, how much does it show? What's your actual size of storage and actual size of your partition volume in a computer?
सर लाइक माय लैपटॉप हैव 1 TB ऑफ लाइक स्टोरेज ना, तो
Mhm.
इसमें आपका सर 2 मिनट। सर इसमें 594 GB कैपेसिटी है।
Okay.
हाँ जी सर, और फॉर्मेटेड भी इतनी है, सेम है। तो सर 594 ही है जो शो कर रहा है, मतलब हाँ 594 शो कर रहा है।
You have 1 TB in your computer, and how much does it show? Total space?
594 GB सर।
I think the numbers are wrong. 1 TB cannot show 594.
931 around.
Yes, sir. It is around 935.
Now you are coming closer.
सर मैं दिखा सकता हूँ आपको, मतलब इतना ही
You
शो कर रहा है।
you can show your screen.
हाँ सर मैं आपको दिखाता हूँ।
Let me stop the stream.
स्क्रीन 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 कहाँ से शुरू कर लिया? सर विजिबल है?
Yeah, it is visible.
तो यहाँ पे सर सर शो हो रहा है आपको?
Yeah. So it is 954 GB.
यस सर 954, लाइक डिस्क में एसडीडी एसएसडी है ना, तो हाँ इतना कर रहा है।
954 GB. Yeah. But the previous number is very incorrect. Okay. So 954 GB. Okay. In 1 TB,
यस सर।
954 GB. It's for NVMe. You have an NVMe in your laptop. You can stop the screen. Let me share
Okay.
you my screen.
सर तो एनवीएमई आते हैं ना लैपटॉप्स में, तो मतलब वो
No
साटा तो
laptops.
हाँ साटा तो पुराने उसमें ही आते हैं तो।
But as a secondary storage in your gaming laptops, they have two storages. Okay,
यस
one for OS and one for your data. Okay, so for OS,
Yes.
for like high amount of data is to and fro. Okay, so it's NVMe because its bandwidth is high and data is HDD. Okay, this is the basic configuration of a gaming laptop in India. Okay, so now let's come to the discussion part. What is the difference? Why you have a 1000 GB showing 954 GB? What is the difference behind it, and why there is so? Okay, let me also give you a. You can go back into your computer for 500 GB. It shows you 465 GB in hard drives, especially. So, what is the difference? Why is the difference? Can anybody answer this?
Previously, you told us background apps application will run some
Maybe, sir, it
spaces.
covers recovery file and some files that we can't see.
One by one. One guy is saying background apps, size, storage. Okay. One person is saying that deleted data goes here.
due to
I mean,
mathematical decimal. Yeah.
sorry, come again.
So like that calculation numbers also. Like whenever we have just any storage, so like the real capacity is lesser than due to mathematical like decimals reason. I think.
Okay, so somewhat is correct. This is the correct answer. Somewhat is correct. The decimal calculation. Okay, before going further, let me give you example. 1 liter of milk has how much ml of milk?
1000.
1000. Similarly, 1 kilometer is equal to 1000 meters.
Yes, sir.
Yes.
But this doesn't work in computer. Okay, in computer
Yes, sir.
language,
When it comes 1024. Yes.
yeah, 1024 subunits. It makes 1 unit. Okay, so there are total of 4 manufacturers in the entire world of hard drives. Hard drives, OEMs means manufacturers. In complete world is one is Seagate, one is Western Digital, one is Fujitsu, and one is Toshiba. Apart from these 4 manufacturers, nobody manufacture hard drives as of today, as of today's date, since from last 10-12 years. But there were different manufacturers back in early 2000 era, but they are small players and they get merged in mainly into Western Digital and Seagate. Okay. There was Samsung also, but Samsung is taken over by Seagate. And there were SanDisk also. SanDisk is taken over by Western Digital. Okay, mainly it's flash storage business. SanDisk was never in hard drive storage business. So when they manufacture hard drive of any capacity, they have a standard set with each other that if they manufacture 500 GB hard drive, then other player who is manufacturing 500 GB hard drive, the physical parameters, the software parameters, the designing parameters of hard drive, it should remain same. It should remain same. There is a treaty is signed in between those players. Okay, let's say Seagate is producing a 500 GB hard drives, and Western Digital, which is called WD, is producing a 500 GB hard drive. Okay, so for a fixed storage and fixed protocol, the design parameters, the storage parameters, the geometrical parameters, all should be same in order to make the trade viable, make the trade more professional or more possible. Because if a Russia is producing a storage device, it should be work in the Middle East region. If US is producing a hard drive, it should be work in Japan market, in Japanese computers. This is how they design storage devices in terms of storage and design parameters. So let me give you a very smallest unit of storage device in which data can be stored. So can you name, I have explained it in my previous session, the smallest unit in which data can be stored is called as,
KB, sir.
sorry, come again?
Kilobyte.
No,
Kilobyte.
no.
Nanobyte.
There is nothing nanobyte. There is no,
I'm sorry, sir. I'm just kidding.
Bits.
no problem, no problem. It's called sector. Okay.
सर इन टर्म्स ऑफ मेमोरी पूछ रहे हैं कि यूनिट्स अच्छा सॉरी यूनिट्स पूछ रहे हैं ठीक
Yes. Okay.
सर मेमोरीज में तो कैश होती है ना रजिस्टर
I-
रजिस्टर मेमोरी रजिस्टर
Register is the physical thing. Register is a physical thing. Okay. And the smallest unit in which our data can be stored is called sector. And one sector is equal to 512 bytes. Okay. This is the general criteria of each and every hard drive in the entire world. Okay. Now, there are some general rule that whoever produces among these 4 players in the market, whoever produces 500 GB hard drive, they must have a set number of sectors inside it, and which are 500 GB have 976773763 976773765 65 or 66. It means 3, 2, 7, yes, 97 crore 67 lakhs and 73,765 sectors or 66. The last number, this could be 6 or 5. Okay. So these are the set parameters. These are the set parameters. The number of sectors, whoever produces a 500 GB hard drive, they must have this kind of sectors. The last sector, it could be 66 or it could be 65, but not below than that, not above than 66. Okay. So now let's go to calculator thing. And 97673736765. This is the amount of sectors you have. Okay. Now one sector has how this much bytes. So this much sectors has how many bytes? What I have to do now? किसको किससे मल्टीप्लाई करेंगे?
512.
Yes, 512. So a 500 GB hard drive, you have this much of bytes. Now you have to convert these bytes into kilobyte. What do you have to do? These bytes need to convert into kilobytes.
So I think it's divided by 2 to the power 10.
No, it should be divided by 1024. And whatever answer comes, it should be divided. It is kilobyte. Now I have to go to megabyte. From smaller unit to higher unit, I have to divide. Okay, divide by 1024. This is megabyte. Now I have to convert to gigabyte, GB. Again divide by 1024. So 465.76 GB for a 500 GB hard drive you will have. Okay. Now instead of going 1024, if you take the factor of 1000, then you will get the number of 500 instead of 465 GB. So it's just a mathematical representation of if you have 1 terabyte hard drive. 1 terabyte hard drive have generally how much 1 terabyte in SS in HDD it is 981 GB. Okay, so this is just the difference is the mathematical representation of main unit to 1024 units. So if anyone asks you where does the size goes for deleted data or not, so you can say you have only 465 GB of data in which you can present your data or delete your data, or data which goes into unallocated region, it is still goes in 465 GB. So if you are going to image a physical image of a hard drive you are going to make, then you have to create a physical image of 465, take the source as it is. Then it will have your live data, present data, deleted data, and allocated data. Okay. Now let's go back to FTK imager. Okay. So image is created successfully. and the time it will take around 12 minutes 11 seconds. And image summary you may have, these are the notes which you have put on. Okay, these are the how many bytes per sector your source drive have. It's 512 bytes as I told you earlier. And this is the checksum value, the hash value. Okay, the image started at this point, the image completed at this timestamp, and where you put your hash, these are the original hashes and these are the computed hashes. Okay, and both are verified, and here it is called verified. Okay, so this is the acquisition of a physical drive. Okay, now let's close it. Or this is again the summary comes in this way, the hash values. A text file, a log file is also created at this location, D test drive and pen drive. Now let's go to this location and D drive and test image. This is a physical image. Since I have taken 0 fragment, that's why I have a 0 fragment. I have a single file of 7.27 GB. My original size of storage is how much? Is you can see over here, it's 15.2 GB, and it has what? It is almost empty. Let's say but for 15 GB data, which is empty, it has created 7.27 GB. So it must have some entries which are deleted. That's why it's consuming some space. So 7.27 GB. This is the log file which I have discussed with you. Okay, this is the log file. So later session, we will again do some acquisition of different pen drive with different entries, and then we'll explain it. And I'm going to share you this software now, and you have to do by yourself and try to image it, your pen drive into your computer or to any external drive. And some literature also I will share to you. So this is about acquisition session for today. And we will connect, there is one day we'll connect day after tomorrow on Wednesday. Akash will share you the time in Tuesday. If you have any queries, you may ask, and else we will conclude today's session.
Sir, Celebrite is same or different?
Okay, Celebrite is a OEM of mobile forensics software. It's used for acquisition of mobile data and analysis of mobile data. It's different.
Thank you, sir.
Okay, so let's conclude today's session. I'm going to log off. Thank you, everyone.
Thank you, Mr.